Here are some crazy facts you didn't know about the moon. 1. Moonquakes. Just like earthquakes on Earth, the moon experiences quakes, but they are caused by different factors. Moonquakes can be shallow or deep, and they can last for several minutes. Some moonquakes are gentle and imperceptible, while others can be powerful and potentially cause the moon's surface to crack. Unlike earthquakes, moonquakes can be triggered by the gravitational interactions between the moon and Earth, as well as the heating and cooling of the lunar crust. 2. Dark side of the moon. The term dark side of the moon is a bit misleading. It's not entirely dark, it's just the side that faces away from Earth. The far side of the moon receives just as much sunlight as the near side, but we can't observe it from Earth due to the moon's synchronous rotation and orbit around our planet. This hidden side of the moon was first seen by human eyes during the Soviet Luna 3 mission in 1959, and it was later mapped in detail by various lunar missions, including the Lunar Reconnaissance Orbiter. 3. Moon's slow retreat. Due to tidal forces, the moon is slowly moving away from Earth at a rate of about 3.8 centimeters, 1.5 inches, per year. This phenomenon is known as the lunar recession. Over billions of years, this slow retreat will lead to longer days on Earth, as the moon's gravitational influence affects our planet's rotation. It's estimated that billions of years in the future, the length of a day on Earth will have increased, and a lunar day will match the length of a month. 4. Moon's ancient surface. The moon's surface is covered in impact craters, relics of countless collisions with asteroids and comets over billions of years. These craters range in size from small pits to vast basins, such as the Imbrium, Serenitatis, and Crisium basins. The lack of atmosphere and geological processes has preserved these craters, making the moon's surface look like a record of its violent history. The study of lunar impact craters has also provided valuable information about the history of impacts in the early solar system. 5. Lunar soil. The moon's surface is covered in a fine layer of dust and soil, known as lunar regolith. The regolith is abrasive and poses challenges for astronauts and equipment. It was formed by the constant bombardment of micrometeoroids over millions of years. The Apollo astronauts described the regolith as a fine, powdery substance that clung to their spacesuits and equipment. Lunar regolith is also being considered as a potential resource for future lunar missions, as it could be used for construction and the extraction of valuable elements. 6. Apollo moon landing. The Apollo program was a series of crewed missions conducted by NASA between 1961 and 1972. The most famous of these missions was Apollo 11, which successfully landed the first humans on the moon on July 20, 1969. Astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface, while Michael Collins orbited above in the command module. The Apollo program included a total of 6 successful lunar landings, with Apollo 17 being the final mission in December 1972. 7. Moon's atmosphere. The moon has an extremely thin and tenuous atmosphere, often referred to as an exosphere. Unlike Earth's atmosphere, the lunar exosphere is composed of scattered atoms and molecules that do not interact with each other. It consists mainly of hydrogen, helium, neon, and other trace elements. Because of its thinness, the exosphere does not significantly affect the moon's surface conditions or the behavior of spacecraft in lunar orbit. 8. Lunar maria. The dark, flat plains on the moon's surface are known as maria, Latin for seas, but they are not actually bodies of water. They are ancient basaltic lava plains created by volcanic activity billions of years ago. The lava flows covered large areas of the moon and solidified to form the maria we see today. The maria are some of the most prominent features on the moon's surface and were named by early astronomers who mistakenly thought they were seas or bodies of water. 9. Lunar dust levitation. During the Apollo missions, astronauts noticed that fine lunar dust clung to their spacesuits and equipment and seemed to levitate above the moon's surface. This phenomenon is due to the unique properties of lunar dust particles, which become electrostatically charged by the solar wind and can levitate in the moon's low-gravity environment. The levitation of lunar dust posed challenges for lunar missions, as it could interfere with equipment and potentially pose health risks to astronauts. 10. Moon illusion. When the moon is near the horizon, it appears much larger than when it is high in the sky. This is known as the moon illusion, a psychological phenomenon that scientists are still trying to fully explain. The exact cause of the moon illusion remains a subject of debate among researchers. Some theories suggest that the moon appears larger near the horizon because of the way our brain interprets visual cues in the context of the surrounding landscape. 11. Moon's extreme temperatures. The moon experiences extreme temperature variations due to its lack of atmosphere. During the lunar day, lasting about 2 Earth weeks, surface temperatures can soar to around 260 degrees Fahrenheit, 127 degrees Celsius. The lack of an atmosphere means there is no medium to trap heat, causing temperatures to fluctuate dramatically. Conversely, during the lunar night, which also lasts about 2 Earth weeks, temperatures can plummet to about -280 degrees Fahrenheit, -173 degrees Celsius. These extreme temperature swings are one of the many challenges faced by lunar missions, as spacecraft and equipment must be designed to withstand such harsh conditions. 12. Water ice on the Moon. Recent discoveries have revealed that water ice exists on the Moon, primarily in permanently shadowed regions near the poles. This discovery is crucial for future lunar missions, as water could be used to support human settlements or converted into oxygen and hydrogen for rocket fuel. The presence of water also opens up the possibility of using the Moon as a stepping stone for future deep space missions, as water can be used for life support and to create propellant for spacecraft. The Moon continues to be an object of fascination and scientific exploration, providing us with valuable insights into the early history of the solar system and our own planet. As we continue to study and explore the Moon, new discoveries and revelations about our closest celestial neighbor await us. The Moon's history is deeply entwined with our own, and its mysteries continue to captivate both scientists and dreamers alike. From its ancient craters to its elusive water ice, the Moon is a testament to the wonders of our cosmic neighborhood and the boundless possibilities that lie ahead in the realm of space exploration. With each new mission and discovery, the Moon's story unfolds, enriching our understanding of the universe and inspiring future generations to reach for the stars. Thanks for watching.